Okay, next one is a alternating series test. Okay, so we know an alternating series test, it goes by positive, negative, positive, negative, or negative, positive, negative, positive. Okay, so in general, we know that the limit as n approaching to infinity a sub n equals 0 tells us very little about the convergence of a series, right? However, it turns out the alternating series must converge if each term constantly shrink in size and approach to the 0, right? So what is alternating series test? So in order to use the alternating series test, we need to check the two conditions. Number one is so first of all, a sub n should be greater than 0. So a sub n does not contain the sign. Okay, so when you determine the a sub n, you have to exclude the sign from the terms, each term. If a sub n is greater than 0, then alternating series goes like this, or negative 1 to the n plus 1, right? This one goes by positive negative, this one goes by negative positive. Converges if both of the following conditions are satisfied. Number one, the a sub n, each term has to be approaching to the 0. And a sub n is a decreasing and non-increasing sequence, so which means the next term is less than equals the previous term for n is greater than k for some k. All right. So this does not say if the limit as n approaching to the equal is not 0, series diverges by AST. So in that case, we don't know. Okay. So we gotta move the different test. So now let's try the next one. Example, determine whether the following series converge or diverge. Okay, so make sure, so these are the two conditions should be satisfied to converge. Okay, so the a sub n does not contain the negative. That's what I'm saying. So this is my a sub n. You have to exclude a negative sign from the a sub n. So this is my a sub n. All right. So what we're gonna do is number one. This is a number one. So we're gonna take the limit as n approaching to the infinity. Now the limit as n approaching to the infinity n over 2n minus 1. So isn't it 0? This is not equal to the 0. Right? Okay. So what that means? So this means this series is a diverge. Right? Okay, the reason why, because we know this one is a 1/2, which is not equal 0, right? So by diverse test, not by the alternating series test, right? So by diverse test, we know this one is a diverse because this is not equal to 0. All right, now let's try the next one. So this is my a sub n. So this is my a sub n. Now the limit is n approaching to the infinity n over ln of 2n. So we know it looks like x over ln x graph. So you can just compare. So this is a y equal to x graph. We know this one is a y equals ln x graph. So which one increasing faster? We know y equals x increasing faster than the ln x, right? Which means that when you compare the numerator and denominator, we know the numerator, which is x over ln over 2x, x is increasing faster than the denominator. So we know this one is approaching to the 0. So number one is satisfied. Now number two. So it says that the next term should be less than equals the previous term. So in this case, you're going to choose the two consecutive terms, okay, to see if a sub n is a decreasing sequences. So let me choose a 10 or 11 or 9 to 10. It really doesn't matter. So let me choose like 10 over ln of 20, and I want to compare 11 over ln of 22, right? So if you plug in a calculator, we know that this one, the previous term, is a greater than the next term. So which means this sequence is a decreasing. Since those two conditions are satisfied, we know B is also converge. Okay, C, I don't think we have to use our alternating series test because we can use a direct comparison. Um, okay, but when you use a direct comparison, this one is a bounded by less than equals 1 over n, but we know 1 over n isn't the harmonic. So less than, harmonic is a diverge, less than, diverge. So the direct comparison isn't it less than converge, converge? It's greater than diverge, diverge, right? So yeah, I was wrong. We may not use a direct comparison. We must use an alternating series test in this case because we have a pi here, right? So if you plug in a 1 cosine pi -1 and 1, -1 and 1, so we know this one is alternating harmonic, so which is a converge. So let's check. So we know cosine and pi gives us a sign, right? Because it goes by positive, negative, positive, negative. So we know the a sub n is the limit as n approaching to infinity 1 over n. We know that is approaching to the 0. So the first condition is satisfied. Number 2, I'm going to choose a two consecutive terms, which is a 1 over 10 and a 1 over 11. We know this one is a greater than the next term, right? So we know this one is also satisfied. So we know this one is a converge. Let's try the next one. Again, this is my a sub n. So number 1, limit n approaching to infinity 1 over n factorial, which is a 0. And number 2, let's choose 1 over 10 factorial, 1 over 11 factorial. We know the 1 over factorial is greater than 1 over 11 factorial, so yes, it is a converge. Now let's try E. So we know this one is a sub n. So number 1, limit as n approaching to infinity 1 over n minus 5 to the second power plus 1. We know this one is approaching to the 0. Number 2, so I'm going to choose a two consecutive terms. So I'm going to choose like big enough. So let's choose a 100, 100 minus 5. So 1 over 95 squared plus 1. And the next one is a 101, right? 101 minus 5, which is a 1 over 96 squared plus 1. So we know this one is a greater than that, right? Since these two conditions are satisfied, we know this one is also converge. All right, now the last one, F. So isn't it kind of like the same as a C? So this is my a sub n. Now, the limit as n approaching to the infinity, 1 over n, is it 0? Yes. Pick the two consecutive terms, 1 over 10 greater than 1 over 11, so yes. So we know it looked different, C and F, but then basically, isn't it the same? Except kind of like a sign. It goes by negative, positive, and this one goes by positive, negative, right? So we know this one is also converge. So today's assignments will be, so this is the example 22. This is a very last page. So now this one is putting all together, determine if the following series is converge diverge. Name the test you used and the criteria of each test used. Okay, so this is a homework for today, but you don't have to do F. Just cross out F and M and N and O. Okay, so except those 4, I think you should be able to do the rest of it. Yeah, so please show your work. Okay, so name the test that you used. Okay, and then show your work. And due date is tomorrow, Tuesday. And yeah, turn in your homework in the Dropbox. Okay. All right. Have a good day. Bye, guys.